Hi, so today we are going to see how to work with Web3 in JavaScript. Web3 allows us communicate with the Ethereum network, the blockchain, and also the likes of it, like with Binance Chain, Avax, and the others. So with Web3, we are going to be able to see the transactions on the network. We can send transactions ourselves, see what is mined on the network, and everything. So what we are going to do today is to create a wallet and then read its balance from the network. Since the wallets that we create are random wallets, it could be that somebody else has already created it or sent money to it. So the chances are very, very low, but there could be some money in it. So please don't touch people's money. But I guarantee you there will be no money in this because the chances are like 1 out of a billion. So the first step is to go to nodejs.org and download and install the latest Node.js version. Then we will open our development environment. Here I'm using Visual Studio, and then we create a file and start writing our code in it. But before starting to develop some Node.js and Web3 programs, we need to install Web3, which is very easy. You just need to ask Node Package Manager to install Web3 for you automatically. So you just open a terminal and write the command npm install web3. Yeah, and in Visual Studio, this is how you open the terminal. So I've created a file called 05.js and I will start writing my code here. The syntax of JavaScript is very similar to C, so it will not be that difficult for anyone. So first, we import Web3 library like this. And now I created an instance called my Web3, which is a new Web3 instance. And then we are going to use it for our application. So now this instance will need some settings or configuration to be able to communicate with the network. And for the Ethereum network or Binance chain, you will need an RPC. So an RPC is a service provider which acts as a relay between you or your Web3 instance and the blockchain. And here I'm going to use a publicly available HTTP provider, which is the Flashbot RPC. You can view their websites flashbots.net, which has interesting topics for you. So now that we defined the instance of Web3 and connected it to the RPC, we can use it to do our things. I'm going to start by creating a wallet like this. So with this command, you can create a wallet, and just pay attention that this if that we are writing here, the term ETH is originally written for Ethereum network, but if you're using this Web3 instance to connect to Binance chain or any other blockchains, this term stays the same. It's still ETH, but it might be another network. So it means that instead of this Flashbots RPC, which is the Ethereum network RPC, you can put a Binance Chain RPC address, and then all your program will be running on the Binance Chain blockchain. So now I will log the address of the wallet that we've generated in the console to see if it worked well. There you go. We had some delay, perhaps because we were connecting to the RPC, but then you have the address of the wallet that has been generated for us. Once the wallet is generated, we can access all of its properties. The most important one here is the private key. So let's print out the private key too. To access a private key, we will write my wallet point private key like this. And just pay attention, in JavaScript you don't really have to put the semicolon in the end of each command, but it's better to do it. Okay, there was an error because we're printing undefined, which means a private key perhaps. Yeah, I made a typo. It's capital K. So now you have the private key printed out. So just pay attention, this is the key to sign all your transactions and all your communications with the network. And this is how you prove you're the owner of this wallet. So this is not something that you want to share with others. And just to review the theory, these two public and private keys, the public key being the address of your wallet, are the same and are equivalent, except that with public key you cannot sign a transaction. Or to put it simply, you use your address or your public key for receiving money, and you use your private key to send money. So now we saw how we can generate a wallet and access its private key and address. Let's see how we can read its balance over the network. So to read and print out the balance, we will continue to write our commands. But we have to pay attention that accessing the address and private key of the wallet is instantaneous because the wallet is stored in memory. But then when we want to read the balance from the network, we need to communicate, and this communication always has some delays. And in JavaScript, we have to define an asynchronous function for this. We cannot do it as simple as the other ones, like the address and private key that we did already. So we need to define an asynchronous function, then put everyone inside, and then write our commands. We will see how to do it. So we write async function check, and check is the name of the function, and we put everything that we've written so far inside it. And this is a function that will generate the wallet and then check its balance over the blockchain. And so here we put a wait even for creating the wallet because there could be some delay here. And if this command is not done or finished in time, it will return a promise instead of a valid, and then we will have errors. So first we put an await here, and then we go to checking the balance too. So let's define a variable called balance and then wait for the Web3 to read the balance from the network and put the value inside our variable. And to read the balance of a wallet from the network, we need to use the getBalance function, and as a parameter we give it our wallet address. And now we print out the balance that we read from the network. Okay, our function is good now, so we come to the main part of the code and call our function once. Alright, you see, Now we have our address, we have our private key, and in the end we have our balance, which is unfortunately 0. So an important factor regarding security of your account and your money is that you need to know this create function uses some random functionalities to create a wallet for you. But then, since the random function here is not really random, and then it could have some patterns perhaps, it's possible to give it some string and let it like mix the string that you give it with its own random functionality. And so for others it will not be easy then to regenerate the pattern of the random wallets that you're generating here. So it's just a measure of safety for your wallet generation. Now let's go back to our game, because our function seems to be working well. And what we wanted to do as our fun experiment here is to generate different values, multiple ones, and then check if their balance and notify ourselves if there is some money in it. So here what we do is we add a condition and we check if the balance is bigger than 0 and there is money in the wallet. And only in this case we are going to notify ourselves or print out the wallet address, private key, and the balance. But then we don't want to run this function only once and generate only one wallet. What we want to do is to do it continuously until we reach a winning one. So for this reason, we can use set timeout function, and the two parameters, the first one is the function to call, and the second one is the milliseconds to wait before doing it. So each time the check function is done, in the end it will wait until 500 milliseconds or half a second and then call itself again and again and again. So with 500 milliseconds or half a second delay that we put here in the set timeout function, it will generate and check your wallet twice per second and send the output for us. Now we can use other methods to send this output or notification for us. As we have seen in the other videos, you can use Telegram bots, which are the easiest way to send notifications to yourself or someone else, but on the Telegram application. The thing is, in JavaScript, we don't have, or as far as I know, we don't have a library for communicating with Telegram. But what we can do is that if you've already created a bot for yourself and you have its API token, you can try to fetch a web address, and by fetching that address only and sending the parameters as a get parameter, you can have a message sent to someone. So let's see how we can do that. So the address or the web address that you need to fetch is api.telegram.org/ token of your bot, and then / the function or the command that you want to call, which is send message. And then to this address you need to send certain parameters. First thing is the person or the group or channel, the ID or the number that you want to send a message to, and then the message itself as a parameter text. So here's how I do it. So here I created a Telegram group called Ether Wallets. It's the ID of the group, and I added a bot inside that and made it admin to be able to send messages, or give it the access to send messages. That's it. And here as the message, I will send balance, then space, then the address of the wallet, and then its private key with a space between them. So now what I need to do is to send a message to botfather, the Telegram bot that generates bots for people, and then ask him to generate a bot for me, and then define the API key here. I've already done it, and then I will paste it here and define it as the API key. So now I want to test this to see if it can send a message to Telegram correctly, but then since the balance is never going to be about 0, it will not happen. So I put an equal to 0, so only to check the functionality. Alright, so now I run it. You see we still have the outputs in the console, and I stop it with Control C. And now you see in Telegram we have the same messages. We have the balance, which is 0, then we have the address, and with the space we have the private key afterwards. So just to make it more readable, I will replace the space with a line feed. So it will start by sending the next information in the next line, and the code here for line feed and carrier return is %0A. If you remember well, when printing to the console or into files, the code for CRLF, which is carriage return line feed, is /n, but in the HTTP requests it's %0A. This is the difference. Okay, there it is. We have the 3 parameters that we're sending in the message, each one in a new line. So now you can write this code, let it run, and then whenever you get a message from it, you'll be happy. So again, this is just a fun use case, it's not a real one. But then the important thing to learn from here is how to generate a wallet and how to check the balance of an address or the network, how to communicate with an RPC. And also they say that for the safety reasons and for securing your money and transactions, if you have big applications with lots of transactions, it's good if you could generate different wallets and then send your transactions from them. And I will continue this Web3 series. This was just the beginning. We will see how to communicate with the network, how to see the transactions, and how to find the ones that can be profitable for us, and how to take profits from these transactions. All right, see you next time.